Hello again. Today we are going to see vapor compression AC units, which basically can also be a heat pump. The main thing about this system is relatively old, as you can see, but the good thing about that is it is way more apparent. All the components are here to see, and it is less automated. We have a couple of other systems across our workshop, but some components are not that much clear to see how they perform. So we are going to see this unit and basically see how it works. The basic principle is what you get, you give something, you get something in return. So what you give here is basically generating pressure difference in this system. So what you're doing is increasing pressure using a compressor, which is a highly energy consuming machine, and then again ruining that pressure that you generated on the other side of the cycle to get the temperature difference. So when you increase the temperature, when you increase the pressure, what you get is increasing temperature, which later you're going to use that in your condenser. And then after thermal expansion, when you destroy that pressure and the pressure decreases, the refrigerant will be in a superheated state, and then you can dissipate heat from the environment and use it as an AC from the condenser side. So we are going to see that with more details later when I'm showing each and every components. We will see what are the measuring devices that is used in this system. We have a couple of flow meters used for the refrigerant. We have a couple of pressure gauges and temperature measuring devices for inlet and outlet for each component, for compressor, for evaporator, and for condenser. Later, I'm going to show you a couple of other measuring devices that basically we use those to measure the temperature and also the velocity of speed coming in and out of the evaporator and condenser. So I'm going to show them later to you using a closer shot. So let's go ahead. Let's see how the cycle works and how basically you are using these data from your measuring devices to find your desired parameter from the system, like the cycle efficiency, like the AC efficiency, and the cooling rates or heating rate if you are using this device as a heat pump. Okay. This is the system and its components. As you can see here, this is compressor. We have evaporator and condenser here. And now we can go ahead and see the components with more details. For the compressor side, we have the entering temperature T6 and P6. Here, this is the P6, this is the T6, and also P1, T1 are the leaving temperature and pressure of the refrigerant after it passes through the compressor. Later on, we will go ahead and see the condenser. Here is condenser. As you can see, the entering temperature and pressure are T2 and P2. T2 here, P2 here, and also leaving pressure and temperature are T3 and P3. Later, We have the evaporator in the downside. You can see the entering temperature, T4, P4 is here, T4, P4, and the leaving temperature are measured here, T5 and P5. So basically we use these measurements to find the enthalpy, and we can use psychometric charts to find the enthalpy by having these data. And later we will use these enthalpy to find different parameters of the system, such as the heat flux, and later we can use that to find coefficient of the performance for heat pump or AC machine. So let's get more into details and see what are other things we have here. We can see we have a voltmeter here. We have a measuring device for finding the current in amperes. So these basically shows the amount of electricity that the compressor is using while the system is running. Right now the system is shut off because of the noises it creates, so I want it to be more clear, and maybe at the end I can also run the system and you can see you can have you can see different values on these measuring devices. So we have a couple of other components to explain. This is a receiver, this is a accumulator. Basically they have a role or a duty as a filter. Since the refrigerant is running through the system, there may be some moist and debris included, so this would separate them and make the system run smoothly. Why? Because if there is a moist, also you can see the gases could be extracted using this pipe. So if there is moist, later on when the refrigerant passes through the thermal expansion valve, which you can see over here, then those water may frozen and clog this thermal expansion valve. So this is the reason we have a receiver over here where the refrigerant is liquid, and this is the accumulator when the refrigerant is in vapor state before entering the compressor. It has more or less the same use. It can basically release the make the refrigerant pure and make sure that it runs through the systems smoothly. Furthermore, if we want to assess the performance of these heat exchanger units, I mean the condenser and evaporator, we need to have information about the incoming, as you can see, the incoming air using a forced draft, which is fan devices here, and the outcoming from the front face of these condenser and evaporator. We need to measure the specifications of the air input air and output air. So we need a couple of devices that I'm going to introduce to you here. One of them is this device, which basically is an anemometer. We have different kinds of anemometers available, but this one is Wayne anemometer, which basically relates the rotational speed of these vanes, these turbines, to the velocity of air. So it is already calibrated, and once you put it in front of the condenser or evaporator, which blows air out, it will start to rotate and show and tells you what is the air velocity at the outlet. And also this device could be used to measure temperature. as you can see, this section is used for measuring the temperature. That element is used for temperature measurement of the outcoming air. You can see other details. These are just the start and turn on, turn off buttons, and nothing more to see. Next device that I'm going to explain to you is basically, again, a temperature measuring device, but this time it is used to measure the wet bulb temperature of the air. So how it works is basically there is a storage tank for water that makes this this material wet. So later on we are going to rotate. We will rotate it in front of our heat exchanger to find the wet bulb temperature of the outcoming air. So as you may know, if the this wet bulb temperature is connected and related to the humidity of the air. More humidity, less difference in the wet bulb temperature and the measuring temperature. And if less humidity, this difference will be larger. So finally, to be more specific about thermal expansion valves, as you can see, we have two-stage thermal expansion valve, this side and this side. You can control the amount of refrigerant passing through using these valves over here. So basically, you can use both of them or one of them, or that is basically how much the capacity or flow rate of that is defined by the capacity or flow rate of the refrigerant. So now that we know all the measuring devices, we can basically find the efficiency of this compressor. As you know, we got a couple of info of the input electricity to the compressor, and then we also have the output. We can calculate the output enthalpy of the refrigerant using the temperature and pressure measurement, and having those would give you enough information for calculating the efficiency of the compressor. Also, the same could be applicable for the cooling rate of your AC unit. You have the input energy to the system, and the amount of cooling or dissipated heat flux that you get from the system could be calculated from this temperature and pressure that I have already explained to you. Setting these objectives, you can later upgrade your system or update this system and modify it to your need and to the objective that you chose, and let us know why you decided to upgrade the system in such way, and how it helps you to calculate your desired parameters of the system. Okay, now I have started the system. You can also see how it works and how it performs. Basically, what I did is I started the compressor using this button, and also defined what fan speed do I need. So this is the fan speed control for the condenser, and this is for the evaporator. So, and then after a few minutes, the system will be in a steady state condition. So you can basically get your measurement and calculate the desired parameters in the system.